So one of the first questions is how did these various polymer compositions that we saw yesterday, when these are a variety of polymers that are in the that were presented yesterday. There are mixes, there are impurities, and they all contribute to the complexity of the recycling of microplastics. So how does this affect cost-effective solutions to isolate and recycle microplastics? Bruce, you want to start?
Well, just starting, I'm from basic energy sciences, so I tend to start off with simple problems, right? And even just starting off with the simple polymers, right? The fact that today it's primarily just PET and polyethylene that are recycled means, that's largely because of their melting point, right? So that is a key property in all of these. The fact that with some of these others you have to go to much higher temperatures to actually reform them is a real issue, right? It leads to breakdown. So part of it is just the composition of the polymers themselves. PVC is a little bit difficult because it's got chlorine in it, right? And you create all these chlorine products, which can be nasty if you try to do things with it. So, I think there's the kind of just the physical properties to start off with. I mean, if you're going to, and for upcycling for chemical processes, you do need to raise the temperature up, right, to get these things so that they're somewhat mobile. But I think the real advantage there is you don't have to go all the way to where they're starting to flow. We're seeing evidence that these polymers, when they're in contact with catalyst, there's an example out of argon where they've taken strontium titanate nanocubes and dressed them with platinum nanoparticles, right, small, and those things disperse on the faces of the cubes. And having those in contact with the solid actually creates, you take it's polyethylene and it goes to something that's equivalent to a lubricant, right? Fairly monodisperse in terms of the size range. And so, those kind of issues I think are going to be important as we move into the chemical processing of these, is what the physical properties are. I think in terms of design of materials, right, creating links in those, the ones today are primarily backbones with just carbon-carbon bonds, which are rock solid. So putting other types of links, ester links in those, tends to make them more easy to access in terms of the chemistry that you want to do. I guess the other thing is, at a very fundamental level, the one thing that you're always competing against is thermodynamics, right? If you think about polymers, they're highly organized, right? And they're very stable at low temperatures because of the strong bonds. But as you go up in energy, actually entropy becomes your friend in terms of going to back to smaller chunks. You get back a lot in terms of free energy from the entropy. And so that's the other driving force that we got to figure out how to deal with. And so in terms of designing new polymers, I think I'm getting to one of the other questions already, but I think that's thinking through the thermodynamics, which the catalysts are not going to be able to deal with, right? Catalysts don't affect the overall energy of the reactants and products. They can lower barriers in the middle. So those kind of issues, I think, are going to be critical to deal with as we think about the chemical upcycling of these.
Yeah, I just had a comment in terms of design recycling or design degradation. I think one of the things that you guys may or may not be aware of is that some bags, like consumer trash bags or shopping bags, they were designed to break down once they get into the environment. They incorporated some titanium dioxide into those plastics. And I think that's kind of like ironically, a two-edged sword. I mean, you can get the breakdown, but then you're generating much more microplastics in a much shorter cycle. So I'm not sure if that's beneficial or if it's at this point harmful.
I actually am very interested in this upcycling discussion because in the developing markets where we don't have the infrastructure for collection systems, if there's an upcycling of value from these materials, maybe that then can drive the reason to bring those infrastructures in place where that we don't have the money to bring those. All of a sudden we have a money incentive to bring those into place and for the society to collect those. Because right now, when you look at those economies and collection, there's also the entire picking economy that exists where people go and pick through the waste and they get that. So if we change what we're using, what is going to be that economy that replaces that? Or are we going to put in place infrastructure that can handle collection? And so if there's a real value to the material such that the money can flow, maybe that is an option then where recycling has not been there before.
Rebecca, do you have any comments on the topic?
I think the other panelists have covered this one. But
Okay.
Yeah.
Okay. Because during the presentations, it's interesting to looking at the data. You know, you have these polyester, Kathleen, in your presentation that biodegradation. I thought polyester would readily biodegrade versus something a hydrocarbon based, a polyethylene, because you have to break a carbon-carbon bond versus an ester bond using. So why is that? Is there an understanding of the difference? But then at the same time, when you mix that, you know, polyester with fabric, the cotton material, then it degrades much faster. Is there a better understanding so that, you know, they can develop something, in the compositional wise, they can look into that more carefully?
So in general speaking, ester bonds are good bonds to put in for microbial attack. There's a lot of esterase in the environment, and in general, ester bonds can be attacked. But when you start to add them into polymeric backbones, and depending on the structure and how many ester bonds you have and where, then all of a sudden you can see that you're not breaking down your materials. Or you may break them down in, say, one step, but you don't mineralize it. And so you don't see a real carbon release gain if you're following CO2, which is completely mineralizing the material, the entire backbone, and down to CO2.
Just
Yeah,
make
go
one
ahead.
comment. I think Kathleen alluded to it, but I mean, the structures of these, right, whether they're crystalline or amorphous, that really does impact their stability. And I'm not sure exactly what the polyester does, right, but it can. There are those kind of factors as well that are, I think, really important in terms of your ability to do something with them.
Well, I think typically when you polymerize, if you look at a monomer compared to a polymer, the reactivity goes down as you polymerize because you have steric effects that becomes very apparent, so it's much less prone to attack in general.
Yeah. That too.
I see the synthetic chemist in you speaking about that. I'm a synthetic chemist, so maybe we'll start with some questions from the audience. Go ahead.
Okay, can you hear me? Okay, great. Well, my name is Suhail Al-Abid. I'm with EPA ORD. First, you had excellent talks, and I really appreciate all the information that you guys provided. This is more of a comment rather than a question. We need to develop a toolbox for this particular problem of the plastics, and I'm going to say nano, micro, mega, whatever you want to call it. First of all, maybe we should think about this as materials rather than waste. And when we start thinking in that way, then maybe we should have another part of this toolbox that talks about beneficial use of these materials. whether you're collecting them from the ocean, from the sludge from wastewater treatment plants. The beneficial use might be economically more feasible in certain situation than, for example, the recycling. And recycling might take a lot more money to do the recycling compared to the beneficial use that you could use the material as is, but it could be used to either strengthen another material, it could be a fill for another material that you have to mine or you have to use. So I would encourage everyone to start thinking of adding that to the toolbox. Once we define that this is a problem, which I think we all agree it is, nobody yet sure what's the impact on whether it's the marine environment or human or so on. We're still looking at the risk of those. But in the meantime, we start thinking in those terms rather than limit the toolbox to very maybe economically not feasible to do and not necessarily worldwide is accepted. We cannot have part of the toolbox that apply to well-developed countries with very large and strong economy compared to other countries that they cannot do that. Simply, it's just not possible. Well, this is a global problem. So if they cannot solve what they have in these underdeveloped countries, then we're going to have to deal with it too, one way or another. So economically, it's going to affect everyone. Thanks.
Yep. Thanks so much for that comment. So there was a lot there to unpack, but I do think you brought up some really important themes. So certainly I think the importance of reframing this issue as recapturing value and understanding the importance of kind of the cascading value of materials, right? So we want to recover as much as possible and then have it be recirculated where it's maintaining as much of its value as possible. So I really appreciate that you brought up that theme. And I think it's important to acknowledge that, as you said, yes, the incentives don't exist for that system right now, so we need to think about how to create those incentives, but also, as been touched on a couple of times, products need to be designed with those considerations in mind, because that's a direct factor in how that material can be recovered. I also think there is, as you were kind of alluding to, a tension between wanting to have general kind of solutions, which is very important, but also acknowledging that countries do have different technology and infrastructure available to them. And I think that that's going to be really crucial in understanding where we can kind of deploy which tactics. So hopefully that's kind of a helpful comment in response to your comment.
Yeah, I just want to add that I've always said that one of the best environmental laws ever written was the 2.5 cents CRV value that's attached to recycling cans. Because if you walk down the streets anywhere, you don't see cans lying in the gutter or on the sidewalk.
But also at the same time, let's say in the developing countries, because of these problems, they may come up with more economical solutions. They may come up with more cost-effective solutions. It's not always exporting something that is very fancy, expensive to those economies. Jennifer, you have a question?
Yeah, so Jennifer Lynch, and for this conversation starter that I have, more comment, but also sort of a question in there, I'm coming to you with my Hawaii Pacific University hat on. One of our 50 states, that's Hawaii, is in a crisis mode because of this problem, and I think it's important to mention that here. Our volunteer beach cleanup crews are removing 20 to 40 metric tons of debris from a single beach every year. And as of last week, our beach cleanup crews were removing microplastics off of Kailua Beach, very close to my home, piling them up in one day that stood waist high on a tarp. So we have a crisis. There's urgency for solutions. And when I stand on the beach and I think about where is this coming from, what are the solutions, I can point to two things based on our research, based on what we see on the beach: offshore fishing operations and lack of infrastructure cleaning up the waste in the developing countries around the Pacific Rim. When I think then about the causes of those things, I think of market forces, and I think of municipalities and tax systems that don't exist. I also travel a lot to places where literally the people don't have the ability to hand off their trash. Their trash goes in their backyard or in the canal or in the ditch of the street. That is their waste disposal process. I would love to hear more, mostly from Kathleen and Rebecca, about the term extended producer responsibility.
Great. Well, thank you so much for framing that up and for reminding all of us the implications of this crisis, which are very real and pervasive for many communities, both human and other communities. So extended producer responsibility, or EPR, is getting a lot of attention in the policy realm, particularly in Europe, but also elsewhere. So I primarily work with the corporate sector, so I'm not a policy expert, but essentially, as I understand it, it's kind of a push to advocate for the importance of corporate actors to take responsibility for plastic that they put out on the market, right? So acknowledging, as we do, that this is a complex problem which all stakeholders have a role in, right? Government, private sector, and people. This particular suite of policy actions is focused on encouraging things like take-back programs, measures that are providing incentives, and also mandates for companies to recover all of that plastic, right? And you can see from the goals of some of the programs we're working on that I mentioned in my talk, that ambition for recovery and large ambition is very important to address the urgency of this problem. But as you also mentioned, right, it is a complex thing. So that is one tool in the toolbox, so to speak, and policy is extremely important. And there are others, whether it's related to municipal infrastructure, wastewater treatment improvements, and all of those are important as well. Yeah.
I have nothing to add. That was a fantastic explanation.
Thank you. Okay, Greg, go ahead.
I have a question about the broader economics. Maybe we can add it to the toolbox. Greg Zaris, ATSDR, but I'm speaking from my former position as a mayor for 10 years of a small city that we really had to deal with many forms of litter and how it was impacting our beautiful lake and how people enjoyed our wonderful environment. And that is, there's other economic benefits, and I wonder if anybody studied it, of moving towards plastics that are more easily recyclable, or using the beeswax as an option. There certainly wouldn't be a bad thing to start focusing on bees, or maybe replacing tires. I don't want them to not wear because we need them to stick to the roads, but maybe entirely creating hover cars. So if someone was to look at a whole, a great picture of substitutions and how that can end up giving economic benefit.
So maybe I can just take a crack at it, and then others please weigh in. So I think first, in regards to the part about recyclability, I do think that this is a really important question that a lot of people are grappling with. So the organization that I mentioned earlier, the Ellen MacArthur Foundation Global Commitment Platform, they require companies to report on for different products to what extent is it recyclable in the local infrastructure. So this has prompted, a lot of interest in understanding, well, how much do we actually know about those thresholds of recyclability, right? And I think for sure economics plays a big part in that, because if there's cases where we can demonstrate that can make a difference in the economics of recycling at a local level, then that could be really impactful. In terms of that in relation to substitution, again, I would say that it's really important to be holistic and understand in which cases it's appropriate based on how the product is used and how it is likely to be disposed of. And getting back to some of the really important points that Kathleen brought up in her talk earlier.
Yeah, I've seen examples where that certainly didn't pan out. If you look in terms of like diapers, there was a claim at one time that if you use just cloth diapers, they can minimize the amounts of waste that goes into our landfills. But I've seen other analysis that shows that if you use cloth diapers, there are a lot of negative sides to it, and I'm not sure how in the end it sort of worked out, but I don't know. We have to be very considerate of a very holistic view of these recycling efforts.
Yes. Certainly MIBK substitution is a lesson to learn from.
And I'll just add, too, that we need data, right, to back up all those decisions. So we need life cycle analyses and information that can show us what are those trade-offs quantitatively. So thanks to everyone who's doing all that great work.
I'll take two questions from the online questions. They're related. So one is, could the biodegradability of plastic lead to generation of micro or nanoplastic particles? It looks like it's for Kathleen. And then are there any methods developed to increase the recycle or reuse of PET bottles that are filling up landfills?
You'll have to remind me of the second question after we do the first one.
Okay, sure.
So, of course, if out in nature, if we have a bottle or anything, any weathering process, and it's not just biological, photo, oxo, UV radiation can take that plastic and create small fragments of plastic that turn into microplastic. And we heard a lot about that yesterday and what we're finding out in the environment. So the reality is that you're typically going to need that microbial process to take you to the final endpoint of mineralization. And that's where you're evaluating whether you can actually have an alternative that can get you from just fragmenting into pieces, which can remain for long periods of time in the environment, to completely mineralizing so that the material is no longer present in that form in the environment.
Yeah, and the second question is on the if there are any methods developed to increase the recycle or reuse of PET bottles. I guess it's polyethylene terephthalate bottles that are filling up landfills.
Oh, I was just going to say there are many. I'm not prepared to speak to them all in detail, but maybe Bruce, do you want to?
I don't know
Yeah.
probably know the landscape.
But yes, there's a great deal of interest on that right now. Every Bottle Back and other corporate and kind of industry-wide initiatives that are happening on that. So that's a big area of interest. I'll also just add on the first part of the question in terms of the biodegradation, also important to remember, like we've talked about several times in terms of where the product ends up, that it might differ a lot if it's in an industrial composting facility versus ending up in nature, being littered, et cetera. So those factors are important in terms of how it's going to break down over time as well.
I was just going to add that I think with PET, it is one of the easy, it's already being recycled. And so I don't think there's a limitation there. I think actually it is a good candidate. It's a low-hanging fruit in terms of being able to chemically upcycle it as well, right? Or actually just recycle it. So I think it's one of the ones that we'll probably see addressed early.
Good question. Go ahead.
Hi, I think some of those questions, Kate Beers from NIST, bring up a really important point, which is you said that in your resource tool, you grade the sort of destination of the waste based at a national level on how the waste is managed. One of the things we've tossed around at NIST is perhaps getting more granularity on where waste is managed, especially in the United States, because it is so incredibly heterogeneous. And it might be better to have more regional information. We know that our rural areas don't recycle as much. It's very difficult for them. The variety of technologies is widely varying and has varying degrees of economic and just technology efficiencies. So I would be curious to know, I mean, Los Angeles, Hawaii, small towns, I'd be curious to hear from everybody, especially the panelists, how useful you think it might be for an agency like NIST to do a survey a national survey of our performance metrics regionally, and perhaps a finer grain scoring and sharing of best practices of what we're doing with our waste.
Thank you so much. Yes, I think it would be incredibly useful. That is something that we do struggle with a lot in terms of how to inform decision-making given the data that's out there. We know there's a lot of variability, but we don't have the information necessarily to back that up. So, of course, challenging at a regional level in the U.S., yes, but even more challenging in many countries abroad where we have just kind of different levels of information, reporting different things, varying levels of data quality. So it's a really big challenge and would support any kind of efforts to be kind of more comprehensive and share that information publicly. Sounds great.
Go ahead.
Yeah, following up on my question from yesterday when I was asking about phthalates and BPA leaching from old wave plastics, now when we're talking about biodegradables or things that can cycle and we can get the monomers back out of them. My question about the newer plastics is, again, are there polymerizing agents, catalysts, preservatives? We've heard about environmental phenols that can be leached out of plastic materials. What other chemistries come along with some of the newer plastics?
It's a great question. I don't have a comprehensive answer by any means. I would say that looking at all the additives that go in and those type of things is something that we do need to worry about, and it gets into that kind of second priority research opportunity where you have much more complex systems that you're working with. And so, again, that's brand new. I don't think anybody's really touched the chemistry of those systems at this point to see what the byproducts would be from any kind of chemical processing of those, chemical upcycling. So that we'll have to look at as we go forward.
Or just simply, if we're breaking down these biodegradables from PHBV, is it? Is PHBV, the valerate, the butyrate, the oxybutyrate and oxyvalerate, have they been tested in mammalian or in vitro systems to understand if it is leaching or forming monomers from those? What is there a concern there?
The polyhydroxybutyrate valerate backbone has actually been studied quite extensively for about 20 years with everything from radio-labeled materials on different portions of the polymer to just mineralization studies. And it actually completely mineralizes under aerobic and anaerobic conditions in quite many environments. The questions of additives needed to get to other properties as you take that polymer and make it into other materials is quite varied depending on how people want to apply that material. But there's no reason why you couldn't ask the same question of the additive individually, first off, and say, is this one going to biodegrade? Are we worried about it? If all of the PHBV biodegrades and this is left, what does that tox profile look like, and what's its risk assessment look like? Or we could also do it as a mixture as well, right? But we need to be asking those questions, I agree.
Alan Burton, University of Michigan. Reportedly, almost half of the plastic in the Pacific Gyre is fishing nets and fishing lines. I haven't heard anybody talk about that. Is there any efforts going on to deal with that industry? What kind of plastic are fishing lines and nets typically one kind of plastic? Could it be improved to use something that's more biodegradable?
Thanks so much for that question. So yes, definitely a significant source of impact, causes entanglement for wildlife, a variety of other issues. So there are some platforms and programs working on this. Ghost Gear initiative, I think, is one. There's others. And I know some of our global WWF offices are doing various levels of activities on those. In terms of what material it's made out of or what properties it would need to have if it was going to be redesigned, I'm not sure, but I do wonder if there's also a need for considering policy relevance here in addition to the material itself in terms of, again, kind of committing internationally to stop these forms of pollution and whether that might be a tool to consider.
And when we think about trying to switch to those larger, more solid form materials from a biodegradation potential, we have to really consider what is the time frame that we want to see it be able to biodegrade within, even in these marine compartments as we're growing biofilms. Maybe as it's used, we've grown biofilms and we're more leveraged to be able to biodegrade more quickly. But that's really going to be the tension, is how fast that can happen versus alternative regulatory methods or changes in how people are using or disposing of those materials. And that's really the tension, I think.
So I just had a comment. It's more raising it up to a higher level. That was one of the questions I had coming into here, right? I mean, initially when we were thinking about this problem, we were just looking at what are the low-hanging fruit in terms of things that we could focus work on to make an impact. But that, I think, will be informed over time by understanding where maybe the more urgent problems are and to understand those problems better and what the risks are with those. So I think these kind of forums are really valuable to bring people like me who are not worrying about, kind of the environmental aspects, but more about the chemistries of the individual systems to understand that so that we can think about where priorities could be placed going forward. So,
another question here is, while alternative materials are highly desirable to minimize microplastics in the environment and can be a potential solution for some products, they may trade off some desirable features of plastics. For example, biodegradable plastic, when paired with appropriate local infrastructure, is one potential solution. They may not be a universal solution due to trade-offs in long-term stability. What research strategies should be considered to address product-specific solutions?
That may be aimed at me, I'm not sure.
Yes.
But, I'll take a crack at it. So it seems to me that, maintaining the properties that we have in today's plastics while at the same time making them so maybe not biodegradable, but, more easily deconstructed chemically or biochemically. I think designing those new polymers and new materials, I think, is a challenge and one that we need to face. So what kind of strategies should we be using? I've heard people talking, and I think it will appear probably in the report that we have coming out, that, issues, things like having materials that are responsive to stimuli of some sort, right? And so putting some pieces into the backbone of these that when you hit them with the right frequency of light or something like that could catalyze a process that would help them fall apart. Those type of things, I think, are strategies that we should be thinking about. I mean, you want to have structurally sound materials, and so you don't want them just falling apart more readily when you don't want them. So those type of strategies are one that could be considered going forward.
So I think this came up from the previous discussion about tire debris. So you want to have something biodegradable, but you don't want a biodegradable tire so that you have to change your tires every month. So that specific, those kinds of challenges can be product specific. You want your tire to last a long time, and for example, and then so I think the question came out of that kind of thought process. If you just focus on biodegradability, but in some cases we still need the long-term stability of the plastics.
Yes, this is essentially the same issue that came up when we noticed the problems with asbestos in brake pads. And I think there it was a safety issue that if you have a degradation in the reliability, then it didn't create an incentive to switch to something that was more benign. So I think this is something that has to be considered when we can look into making changes.
Any other comments? Yeah, go ahead.
I
Tom?
just
Yeah,
was going to
go
say
ahead,
that
Kathleen.
I think as we've been talking about this, and we're kind of focused on end of life, the folks here on the panel, but as we think about any of these alternatives, and I think Rebecca brought it up nicely, we do have to think about the entire life cycle and how we're impacting other processes. Are we using tons more energy, creating a lot more waste to make a new material, just so that we get a small, maybe incremental win at the end of life? And I think we need to really be careful on thinking holistically as we look at these challenges.
Paula, go ahead.
I just want to add one comment regarding the bioplastic. If you see the questions regarding bioplastics, that's a question every citizen have. If you look at the bioplastic market, it seems we are already late. So the current test methods, either ASTM or DIN method, there are around 6-7 methods to test bioplastic, but that doesn't guarantee the safety in different environments. It's just a mere test method. And based on my reading of literatures and what's going around the world, we are already too late in terms of regulating bioplastics. So my comment is we have to work on how you benchmark the bioplastic so that you can de-risk the future. And it's not just the degradation, it's about the chemical, it's about the sustainability and all the related life cycle of it, so that after 10 years we don't sit here and talk about bioplastics, then other things. So that's the biggest question, and the economical advantage and the urgency of finding a replacement, plastic replacement, is actually taken over, not the environmental urgency. So if you see the biggest companies all investing in millions of dollars in producing bioplastic, but the regulation has to catch up quickly to travel along the same direction. And the plastics problem, the number one issue was we did not travel together, as I showed in my presentation. The policy regulation did not travel along with industrial innovation, and also science. Marine science was there since 1870. It took us 1970 to find out where plastic is an issue in marine science. So that we have to make sure we are not making the same mistake in terms of bioplastic. So mere just believing on test methods is not going to solve the future problem. That's my comment. Thank you.
Any comments from the panel?
I think a good example of that is recycled paper products in terms of tissue. I mean, I think the consumers eventually will have to decide whether they want to use recycle for your tissue paper or your napkins versus virgin product. And you can see the market will actually make that decision in the end.
I think just a comment on the bio-based plastics. We always need to be sure if we're talking about that it was bio-based or it's biodegradable. And there is a lot of confusion that happens in that space, and so we all need to be careful that we're not saying that a bio-based material is a solution for something to be out there, because it may not biodegrade at all. And so we also need to, as I discussed in my talk, we need to make sure we're understanding that material, its size and its structure, and whether it's actually going to biodegrade in the environment. If that takes field studies, whatever it takes before we move to that decision point.
I think the next question came up, I guess, similar from a couple of these questions as well. So what are some of the societal challenges in reducing introduction of plastics in the environment, and what are potential solutions? How does this vary regionally, especially in the developing countries. So Tawa also mentioned yesterday about, okay, you do all this here, but then they don't care if you go to India, Bangladesh, or any of these countries there. And same thing with Suhail, who was mentioning about the same kind of related topic. So what are the societal implications of this?
Yeah, so this is definitely a really interesting kind of wicked problem, I guess is the new lingo. So there are a lot of societal components. So of course we've touched on some of the kind of market incentives and the policy challenges. I think also a big piece to be aware of is kind of culture and behavior change components. So things as simple as, our daily lives, how we eat, where we eat, how many times we eat per day, what we do with those materials, influenced by kind of complex social factors, will really have an impact in addition to the infrastructure locally in terms of how much plastic's being consumed, how much, where does it go, and economic growth is kind of amplifying that. And I think it does vary. While again, there are certain trends you can point to, and we know that it's going to increase over time. It's important to remember that there's varying levels of economic growth in the developing world. Some countries might have access to some types of waste management infrastructure that others don't. Weather patterns, stormwater, all of these factors kind of complicate that pathway, right, from consumption to where the material ends up. So solutions, I think, is really understanding interventions that take place. So infrastructure improvements, policies, really robustly understanding their effects. So kind of empirically looking at what's being deployed, whether it's a bag ban or this type of recycling improvement, and where is it working, and what are the factors that we can point to success, what are enabling environments, right? So why might some things work in some countries rather than others? So it's definitely a complex picture, but I think there is work happening on that space, and we can continue to kind of sound the call and say that work is important.
There is one question online. I think it is related. It's a long few sentences here. If I can quickly read, if you're talking about preventing microplastics entering environment, we should include behavioral scientists in this discussion. There seems to be a societal assumption that we must rely on plastics. Let's say the ubiquitous water bottle, yet many of us in this room lived through an era when we did not have easy access to products like this. While I do not mean to diminish the high value of plastics for distributing safe drinking water or for use in medicine, a very important element of this entire discussion is our behavior regarding use of plastics. In addition to looking for alternatives and ways to clean up, we must also address the potential for behavioral change. If we can stop using plastic straws, what are the other possibilities? It's a question online.
Yeah, thank you so much for that. So totally agree. Behavioral scientists are a really crucial part of this discussion. And consumption is a really important thing for us to think about and think about how we're going to tackle it if we really want to address this issue. Again, thinking about all the different angles, right, that we want to approach this from. I think that you see some activities being rolled out, for example, in the EU, where they're focusing on different types of reduction for other single-use materials, where perhaps there's been an evaluation and there wouldn't be a trade-off that would occur, right? So I think that as more kind of governments and actors push for that, we will see where those reduction opportunities make sense. And that's also part of a broader vision of a circular economy, right, which is a crucial part of sustainability. So I don't know if I really fully addressed it, but just to say that I think that it is a really important point. It's something that a lot of people are thinking about. And yes, welcome any and all behavioral scientists who want to work on this.
Well, thank you. I think we ran out of time. Again, I would like to thank the panel, Steve Carr, Bruce, Garrett, Kathleen, McDonough, and Rebecca Traldi. Excellent presentations.